Okay, so let's go ahead and work this calorimetry problem. And in this problem, we're told that we have a certain amount of water that's 20 degrees Celsius that's poured onto a pan, a half a kilogram pan, that's 150 degrees Celsius initially. And they both come to equilibrium at 59 degrees Celsius. And of course, we're assuming that only heat is exchanged between our water and pan. There's no heat lost to any other source here. And we're asked to calculate the specific heat of our pan, and in turn that'll help us identify what the pan is made out of. So let's go ahead and do this problem then. And so our rule for calorimetry is that all of the heat that comes out of the hot substance goes into the cold substance. So that's what this expression is saying here. So let's first calculate the heat that goes into the cold substance, QC. Okay. Well, Q again is MC delta T. So for the cold substance, that's our water. Okay, we're talking about the water here. And the water has a mass of 0.25 kilograms. Now we need to look up the specific heat of water. The specific heat of water is 4190 joules per kilogram degrees Celsius. Okay, so that's just listed in the table in the textbook. And the change in temperature, delta T, well, the final temperature is 59 degrees Celsius. The initial temperature is 20 degrees Celsius. So we go through a 39-degree temperature change for the water. Okay, now that has to be equal to the negative of the heat released by the hot substance. Okay, and so let's calculate negative Q of the hot substance then. And that's the pan. Okay, now the pan, so this is, we're calculating the negative, because that's equal to the positive of QC. So negative MC delta T then. The mass of the pan is 0.5 kilograms, and I'm going to drop our units here because all our units are correct. They're the correct units. Times the specific heat of that substance times the change in temperature. The final temperature, again, is 59 minus the initial temperature, which was 150. So a negative 91 degree temperature change for the pan. The pan's temperature drops by 91 degrees. Now these two things have to be equal to one another. So, so basically this here, okay, that's equal to this. Okay, so you equate those two things, and basically what we have then is 0.25 times 4190. 59 minus 20 is 39. And that equals this, which is going to be 0.5 times specific heat. Now, 59 minus 150 is negative 91. Then we have a negative out here, so negative of that negative is a positive. So then that leaves us with positive 91 out here. Okay? So it's a simple algebra problem now. We multiply these, divide by 0.5, divide by 91, and we get the specific heat of our pan. It's 898 joules per kilogram degrees Celsius are the units, or Kelvin, joules per kilogram Kelvin. And when you look in your textbook, in the specific heat table, you'll see that's, you know, within a fraction of a percent, that's the specific heat of aluminum. So, so this pan then is made out of aluminum.